So this problem here says that there are two rocks floating up in space. We've observed that the first rock has a mass of 3,000 kilograms and an initial velocity of 20 meters per second. As well, there's a second rock with a mass of 1,000 kilograms and no initial velocity. The two rocks collide. Rock 1 hits rock 2, leaving the first one with a velocity of 10 meters per second. And we have a part A here that is asking what is rock 2's final velocity. So with all of this, we have these initial values that the problem has given to us, including the masses of rock 1 and rock 2, the initial velocity of rock 1, the final velocity of rock 1, and the initial velocity of rock 2, which was 0 meters per second. So what we want to end up with is the final velocity of rock 2. And in order to get this value, what we have to do is we have to turn to the momentum conservation principle. And this is just an equation made up of the regular momentum equations, saying that if we have the momentum of one object plus the momentum of another object in the initial state, after a collision happens, then the momentum of one object, if the velocity has changed, plus the momentum of another object after its velocity has changed, these states must equal each other. The initial and the final state must be equal to each other so that momentum is conserved. So if we look at this conservation equation here, if we put it in terms of the two rocks that we have, in the initial state, this would be the momentum of rock 1, which we have rock 1's mass and rock 1's initial velocity of 20 meters per second. And as well, in the initial state, we have rock 2's mass and rock 2's initial velocity of 0 meters per second. So the same thing goes for the final state. We still have the mass of rock 1, and we do have the final velocity of rock 1. As well, we still have the mass of rock 2, but now we are looking for the final velocity of rock 2. So as long as we know that these two states have to equal each other, it's really just a matter of plugging in the numbers that we know and solving for the value that we don't. So then all we have to do is we have to bring this down here and just plug in all of the numbers that we know. So in the initial state, the mass of rock 1 is 3,000 kilograms times the velocity, the initial velocity of rock 1, which is 20 meters per second, plus the mass of rock 2, 1,000 kilograms, times the velocity, the initial velocity of rock 2, which is 0 meters per second. So this is not a number, it's just 0 that we have to add on to our other number. And then this will be equal to the mass of rock 1, 3,000 kilograms, times the final velocity of rock 1, which was 10 meters per second, plus our mass of rock 2, 1,000 kilograms, times our final velocity of rock 2. So now we multiply these numbers out, and we get that 60,000 plus 0 is just 60,000 is equal to 30,000 plus and then 1,000 times our final velocity of rock 2. We just subtract this on both sides. 60,000 minus 30,000 is just 30,000 is equal to 1,000 times the final velocity. and we divide by 1,000 on both sides, and we get that our final velocity of Rock 2 after our collision is equal to 30 meters per second. And with that, we can move on to the next part of our collision problem.